This time, dividers, level 1. Asks both about current dividers and potential dividers. This time it's asking about a current divider. We know the current flowing through this 100k resistor, and we know that it's effectively in parallel with a 27k resistor. So the question is, what current must the current source be producing? A couple of different ways to do that. Just applying Ohm and Kirchhoff's laws, we can get there because we know the current through this resistor, 4.89 nanoamps, and we know the value of this resistor, so we can work out the voltage between this point and this point. That's just going to be the current, 4.89 nanoamps, multiplied by the resistance, 100k. That's about 489 microvolts, and that's the voltage between here and here. Well, if we know the voltage between here and here, then we can work out the current flowing through this resistor. We know the voltage across it, we know the value of the resistor, so the current through this 27k resistor must be the thing we've just worked out down here, currently set to Y, divided by 27k, about 1.8 times 10 to the minus 8, to about 18 nanoamps. And that's going to be the current flowing down through there. Apply Kirchhoff's current law, the current flowing down through here, which we know, 4.89, plus the current flowing down through here, which we've just worked out, must equal the current being produced by this current source. So the current source must be producing this current source here that we've just worked out, that's in X, plus the current that this ammeter is measuring, 4.89 nanoamps. Fine. Next. Right, next one. This is a potential divider. It might not look much like a potential divider, but that's just because the circuit has been drawn in a slightly unfamiliar way. But it is just a standard potential divider. How to see that? Well, perhaps the simplest way is just to rotate these components a bit. If I moved this 2.3 millivolt voltage source just around, which I can do, then I would end up with something that looked like this. And then if I move this resistor up and around here, that would go to about there. And then I just move this voltmeter and this 1K1 resistor down and maybe swap them over, but leaving them in parallel. Then I would end up with this. I'll just zoom that up. Don't know if you can see, but this circuit here is topologically identical to the circuit in the question. I've just drawn it in a slightly different way, but all the same components are there, connected in all the same way. Right, so I can work on this circuit. Now this looks like a standard potential divider. I could define this point down here as being ground, 0. I'm free to choose any point I like in a circuit like this to be ground. Then this is a voltage source, but it's this way round. This is the positive terminal, the long lead. It's telling me that this point up here is 2.3 millivolts below this point here. So this must be at minus 2.3 millivolts. And now I've got a potential divider, which is hopefully a little more obvious. Minus 2.3 millivolts up there. 0 volts down here. What is the voltage there? Standard potential divider equation. The output voltage is the input voltage divided by the total resistance, 820 plus 1K1, multiplied by the resistance that you're measuring over, in this case 1K1. So that's it. V in is minus 2.3 millivolts. The total resistance is 1K1. Sorry, the resistance I'm measuring over is 1K1. The total resistance is 820 ohms plus 1K1. That should be the answer. Let's give it a try. minus 2.3 milli times 1K1 divided by 1K1 plus 820. Fine. Next. Much easier. This is just asking what the standard potential divider equation is, and it's Vin, in this case A, divided by the total resistance, which in this case is 2K7 plus 390, multiplied by the resistance that you're measuring over, which is 390. That'll do. Thank you very much. Next one. What reading should the voltmeter show? Again, it is a potential divider. It's just drawn in a potentially confusing way, but it's topologically identical to a much more familiar form of potential divider, which I could see perhaps by defining this point here to be ground, raising this up, and then moving these two components around the circuit so that they're down here rather than being there. And if you see what I mean by doing that, I'll draw it. I've got 9.7 millivolts on this source going into a voltmeter and a 3K resistor and an 820 ohm resistor there. Right. Now that is topologically equivalent to, let's leave the 9.7 millivolt source just where it was. This wire coming up here, come down there, put the 820 ohms there, move down, but instead of going round, we'll just go straight into a 3K resistor there. And the 3K resistor of the side of it comes round and connects to the bottom of the 9.7 millivolt source. The voltmeter is just across the 3K resistor, but its positive terminal is connected to the end down here. So I've got a voltmeter whose positive or red terminal is on that side. Right, well, I can work out what the voltage across this 3K resistor from there to there is using the standard potential divider equation. That would just be 9.7 millivolts times 3K divided by the total resistance, 3K plus 820 ohms. But that is what the voltage is from there to there. This voltmeter has its positive terminal on the bottom, not on the top. So the voltmeter is measuring what the voltage is from here to here, in the other direction. So what the voltmeter would actually read is -1 times this. Let's try it. -1 times 9.7 millivolts times 3K divided by the total resistance, 3K plus 820. Great. But you have to watch that you get the voltmeters the right way round, otherwise you'll get the answer a factor of -1 wrong. Just do one more current one. Here. Okay, more standard current divider one. You've got 32 nanoamps, and it's dividing between a 3 meg 9 resistor and a 10 meg resistor, so we can apply the standard current divider equation for that. The total current times the other resistor, not the one you want to know what the current is, divided by the total resistance, 10 megs plus 3 meg 9. And that's the standard formula for the current that would flow through the 10 meg resistor, the current that doesn't flow through the 3 meg 9 resistor. More straightforward. Okay, I think that's about enough for level 1.